All right, you guys, I just wanted to work through a few of the questions on your day 7 homework, just because it looked like in class, some of y'all were still kind of confused about how to work through these problems. So in order to use the square root method, okay, because I can't stress this enough, there's 4 different methods, right? We've got the graphing method of solving. We can solve by factoring. We can solve by this square root method. And we also have the quadratic formula, which you're learning tomorrow or in a couple days. So the square root method is a very specific method that can only be used if you just have an x squared term. And because if you only have an x squared term, then you can just solve it like a normal algebra equation and isolate the x term and just move everything to the other side until you get the x by itself. The only difference is some of our answers are going to be pretty and some of them are going to be not so pretty, because in order to solve for an x squared value, you have to take the square root. And square roots are not always pretty numbers, right? So some of our answers are going to be nice and some are going to look kind of weird, and that's okay. Okay, so here we go. I've circled a few questions that I thought I would just run through really quick because I thought they'd be the ones that you might have the most questions on. So here we go. I'm going to work through number 4 really quick. So here is that x squared that I need to get by itself. So we're just going to solve this like a normal everyday algebra equation, right? Here's our equal sign. So we're going to move everything to the other side and get the x squared by itself. So we're going to subtract the 6. Right, and then I'm going to bring down, I've got 3x squared equals, and that's going to give me 192, right? And again, here's my x squared still. I haven't gotten it isolated yet. I have to divide by the 3. Oops, sorry, let me not write in highlighter. There we go. I'm going to divide by 3 on both sides to get the 3 to cancel. And then now I have x squared equals, what's that going to give us? 64. And now that I have the x squared by itself, now I can do the opposite of squaring, which is square rooting, because squares and square roots cancel each other out, and that's how we get the x by itself. And luckily for us, this time, we have a perfect square, right? Your job is to now simplify the square root on the other side, hence the reason why it's called the square root method, right? And of course, that's a nice perfect square, which is going to give us 8, but you also have to remember that -8 also squares to give us positive 64. So you have to account for both the positive and the negative root. And anytime you solve by square rooting, it doesn't matter what math problem you're doing, right? When you solve an equation by square rooting, you have to accommodate for the positive and the negative root of the number you're taking, okay? And then, of course, I'm going to write that as positive 8, 0 and negative 8, 0, and those are my 2 x-intercepts. So if I were to go graph this parabola of this quadratic function, right, that's where it would pass through the x-axis, right? It's going to pass through a positive 8 and negative 8 if I were to graph, okay? All right, the next one I kind of highlighted was number 6. I didn't talk about fractions in class, so I wanted to go ahead and cover this one. So it's really no different than the other ones, right, except when I start getting the x squared by itself, right, we're going to add the 3 first, right, which is going to give us 81x squared equals 49. Now, technically, you should not be square rooting yet because you have not isolated the x squared yet. So your next step should be to divide by 81. And I know some of y'all are like, well, Miss Jester, that's not a very pretty number. I don't want to divide 49 by 81, but it's okay. Oops, sorry, let me write that in gray. Just go ahead and leave it as 49 over 81, right? Because if you put math enter on your calculator, it's just going to take you right back to 49 over 81. Now we have the x squared all by itself, so now we can square root. And I know that looks weird with square rooting the fraction, but they're both very nice numbers, right? Remember, square rooting a fraction means you can, I'm just going to write it over here, right? This is kind of like an apartment complex, right? Everybody's under the roof, right? So if you want to, you can give the 49 his own little personal roof, and you can give the 81 his own little personal square root roof. And those are both perfect squares, right? The square root of 49 is 7. And the square root of 81 is 9, right? So it's 7/9. You can also type it in your calculator and it'll tell you that it's 7/9. And we're never going to give you ones that are not perfect squares. If it's a fractional answer, they're going to be perfect squares, right? When you get to geometry and algebra 2, you'll learn how to handle it if they're not, right? But I also don't want to forget my plus or minus because I just solved by square rooting, which means my two solutions are positive 7/9, comma 0 and negative 7/9, comma 0. And those are my x-intercepts. Okay. All right. I don't really think I need to do number 7. I'm going to take that one off. But I did put 2 on the back page, kind of on my list. So let's talk about number 11 really quick. Okay, so number 11 is different than the ones on the front page because number 11 has a set of parentheses. And so if I solve this like a normal algebra equation, I can't get to that x without first somehow getting rid of the square on the outside, right? But not yet because I have to isolate the squared term, whether it's an x or an x minus 3 squared, it doesn't matter. I got to isolate it. So I'm going to add that 4 over, which gives me 16 equals x minus 3 squared. Now I cannot get to that x because he's in that protected set of parentheses. So the only way I'm going to be able to release those parentheses is if I get rid of the square at this point. So now I'm going to square root because square roots and squares cancel each other out. And that's what's going to get rid of the square, which is also going to allow me to just drop the parentheses because now there's no need for the parentheses since the square is gone. And then, of course, I need to simplify the square root on the other side, which is a nice, pretty perfect square, which is so nice. But it's positive 4 and negative 4. Now, I think most of you guys are doing a really great job of getting to this point, but I feel like some of y'all are still confused of what's happening next. Right? So what's happening now is I still need to solve for x, which means I need to add 3 to the other side to get that x by itself. Right? Now these are like terms, right? Technically what I have now is 3 plus or minus 4, right? I'm literally just inserting, let me do that in pink. I'm literally just putting the plus 3 kind of in the front. So it's 3 plus or minus 4. And I can actually simplify this and do this actual problem because these are constants, and that which makes them like terms. So I can go ahead and combine them. So it's 2 separate solutions, right? So we're going to get x equals, you need to go through and do the math problem the first time with the plus sign. So 3 plus 4 gives me 7. Then you're going to go back through the second time, but with the minus sign. So 3 minus 4 is going to give me my second solution of negative 1. So if you can, when it's a perfect square, right, because that 16 was a perfect square, when that's happening, you're going to, oh my gosh, sorry, you're going to have constants everywhere, so everything's going to be combinable. Right? So my 2 answers are 7, 0 and negative 1, 0. All right. But then I'm also going to work through, this is the last one, number 13. Number 13 is a tad bit different. Same exact process, right? We're still going to start moving stuff to the other side. So here we go. I'm going to add the 2. Right? I've got to get my constants to the other side first, always. Let's see, what's that give us? 150 equals 2x minus 3 squared. Remember, I'm slowly trying to get towards that x. So now I need to get rid of that 2 multiplier in the front, right? I'm going to cancel out that 2 multiplier, divide by 2 on both sides. All right, so now what do we have? 75 equals x minus 3 squared. All right, but now we're to that point where we have that square on the outside, and I have to get rid of him. So this has to be the place where I square root. Because square roots and squares cancel, and that's what allows me to drop the parentheses and be able to get to my x on my next step. Now, I'm not even close to done on this left-hand side because I've got to clean this mess up, right? Remember, on this problem, it was a nice perfect square, and so it worked out super friendly. This one is not going to do that, right? This is a square root of 75, so I need to, which is not a perfect square. So I know my answer is going to be plus or minus something root something, right? So I've got to go off to the side. And I need to simplify the square root of 75 by finding factor pairs. Oops, sorry. So 5 times 15 would work. And then 5's prime. But then 15 can be broken down into 3 times 5. So it's a very short little factor tree. But you'll notice we have a pair of 5s. Which means I can take out a 5 and leave the 3 inside. So that square root of 75 simplifies to plus or minus 5 root 3. And then you're almost done. The very last step is you still need to get rid of that minus 3 over here. So we're going to add 3. Now we're going to do exactly what we did last time. Right? When we add the 3, I'm literally just going to write it in the front there, and that's going to give me 3 plus or minus 5 root 3. Sorry, I'm going to write that in gray. 3 plus or minus 5 root 3. And on this one, that's my final answer because I cannot add 3's to 5 root 3's. I can only add root 3's. This is all right here. This is all a root 3 term. The 5 and the root 3 are glued together to make a term, right? So I can only add 5 root 3's to other root 3's, right? So constants and root 3's are not like terms. So I can't do anything with that, right? Now, over here, my square root was a perfect square. So when I added the 3 over, I was actually able to go ahead and combine these to get these two answers because they were both constants and therefore like terms. I just can't do that over here. So these are my two answers. My first answer is 3 plus 5 root 3. 3 plus 5 root 3, comma 0. Right? And then my second answer is 3 minus, right? I'm using the minus sign for my second answer. So 3 minus 5 root 3, comma 0. And that's how I'm going to write and split my two solutions, right? By writing them as x-intercepts. Okay? I hope that helped working through some problems, and hopefully you're able to finish the rest of those questions if you haven't already. I also do want to point out that number 15, if you look at the answer key, right, notice it only has one solution. That's because it's a double root, right? Because I end up getting plus or minus 0, but there's no such thing as positive or negative 0, which means I'm just getting like 0 and then another 0. So anyway, just wanted to point that out. All right, you guys, I hope that helps. If not, I'll be back in class to answer any questions here in just a few days. Okay? Have a good one, y'all.